Okay, so P is directly proportional to mass. Then P is also directly proportional to velocity. An increase in one causes an increase in the other, and vice versa. Okay, so how will the momentum of an object change if A, the mass is doubled, but the velocity remains the same? If I'm not even calculating, in fact, you can conclude that when the mass is doubled and velocity remains constant, momentum too will double. Okay, so Ishira, when the mass is doubled and when the mass is doubled and the velocity remains constant, Eurasi, the momentum too doubles. Eurasi, are you there?
Yes, please.
If you want to see us using equation, okay, let's take the first mass to be x. Okay, now what is the second mass? In the second situation, the mass is doubled. Okay, m1x v1 v. Then in the second situation, the mass is doubled. M2, we have 2 times this, 2 times x, and then the velocity remains the same. So v2 is equal to the same value of the initial velocity v. So p1 is equal to m1 times v1. p2 is also equal to m2 times v2. If we take a ratio of the individual momenta, we have p1 on p2 is equal to its variables. What do I have? I'm told in the second situation, the mass is double. So M2 is equal to 2 times the initial mass. And earlier I represented M1 by X. So M2 is 2X times the velocity remains constant. So this is V1, or I represented that by V. Okay, let V1 be. So V2 is equal to V. So you realize that this and this would cancel out. X and X will cancel out. You have P1 on P2 being equal to half. What are we looking for here? What are we to look for? What are we to calculate for? Isn't it the momentum of the second situation? So you make P2 the subject. P2 is what you are looking for. So this P2, when you cross multiply, this will be 2 times P1. Meaning if you double the mass, momentum would also double. So the new momentum is equal, the new momentum obtained is equal to 2 times the initial momentum. Please, are we okay? Ishra, are you fine? The second question. The second question said, how will the momentum of an object change if B, the velocity is reduced to 1/3 of its original magnitude? So we have B, velocity reduced to 1/3 of the original value of its original magnitude. So what is being reduced here? What is being reduced? So this time around, the change has to do with velocity. Please let me upload the attendance once again. I'm coming in. Give me a minute. I'm coming. Okay, so this time around, we have a change in the velocity. And clearly, without calculating anything, you can even guess, because momentum is directly proportional to both. So if there is a change in any one, it will affect it. So over here, we are taking the mass constant, but the change has to do with velocity. And so it's obvious momentum too would reduce by 1/3. Okay, if you want to see V1 is equal to M1 times V1. So this is the original magnitude of the velocity. In P2, this is equal to M2 times. Now, in the second situation, we are told that the velocity is reduced to 1/3 of the original value. I'm coming. So 1/3 of the original value. One-third, the original value is V1. So 1/3 of V1 will be the new velocity. So this is actually V2. But V2 is equal to 1/3 of V1. The velocity is reduced to 1/3 of its original value. Okay, so when you put that in P2 as M2 times 1/3 of V1, let's take a ratio of the momenta and then find the new momentum as a result of this change. Here, please, the masses are the same. So M1 is equal to M2. So if you take P1 over P2, this is equal to M1 times V1 over M2, which is the same as M1. So M1 times 1/3 of V1. So you have 1 on 1/3. And what is 1 on 1/3? This is equal to 3. 1 over 1 on 3 is equal to 3. Therefore, let's make the new momentum the subject. Because that's what we are looking for when there's a change in the velocity, which is equal to 1/3 of the original value. So P2 is equal to 1/3 of P1. So that's how this thing is. Hey, who is playing music at the background? Who is playing a Celine Dion? Okay.
Hey.
So that's it. That's the solution to the first two. Eresi,
Sir.
I hope it's not, that's okay with you.
Yes, sir. It's clear now.
Let's look at the last one, which seems to be so strong. Okay, I'm coming. Let me respond to somebody who seems to have misplaced the link. Oh, but I displayed the link on the platform. I'm coming. Okay. Then the last question. Let me repost the link. Somebody cannot link to us. The last question looks a bit technical. My Zoom has changed. Yaba, are you there? Yaba. Yaba is not there. Okay, listen to the last question. 3. The momentum of a bullet is initially 8.25 kilogram per meter. Kilogram meter per second. Can I clean the board? Charlotte,
Yes.
Charlotte, can I clean the board?
Yes, please.
You are the board owner. So let's think through the second question. Then we look at it, calculation on elastic collision. How to use the coefficient of restitution. So the momentum of a bullet is initially 8.25 kilogram. Azada, mute yourself. Azada, mute yourself.
My phone will go. He's calling me. My phone will go. I'm quick.
Of a bullet. So this is 8.25. So 8.25 kilogram meter per second. What is the momentum if the speed of the bullet increases by, so speed increases by a factor of 3 on 2. A factor 3 on 2. And its mass decreases by a factor, the mass decreases by a factor of 3 on 4. So one is an increase, the other is also a decrease. Now, if I have something and I'm told the thing increases by something, it's an add-on, isn't it? If it increases by something, it's an add-on. I'm adding to what I already have, correct? So let's see, solution. Let the initial speed be V. Okay, so if this is being increased by a factor of this, then the final speed is equal to 3/2 of V plus the initial speed V. So this is the total. Okay, my thing, I have something and it increases by maybe 50%. So if the initial is X, okay, the factor, the increasing factor will be 50% of X. So the total will be 50% plus the initial value X. Please, is that okay? Is that okay? Hello, let me get your views. Is this point okay?
Yes.
So this is the total of final speed. What is 3/2 plus 1? What? Add the fraction 1 plus 3/2. Yes, Amma, what is 3/2 plus 1? Hey, Amma, are you there? Yo.
5/2.
So 5/2. Then let's look at the mass is also decreased by a factor 3/4. So let's the initial mass be M. If the initial mass is M, then the final mass, okay, the final mass will be equal to what will be added on plus the original. Okay, so this is equal to, oh, the mass decreases. The mass decreases by this factor. So we have the original mass M minus 3/4 of the initial mass M. And the mass decreases by 3/4 of the original factor. So it is the mass decreases by 3/4. So 3/4 of the initial will be removed. So you subtract the fraction that will be removed from the original mass, and this will be equal to
1/4.
1/4
1/4.
of the original mass. So let's put it in. Initial momentum P1 is equal to M1 times V1. Okay, final momentum P2 is equal to M2 times V2. So let's just substitute. P1, ratio of P1 over P2, because we'll be looking for the second one. This is equal to M1 times V1 over M2 times V2. Okay, let's, my Zoom professional, I have to update it today. So after 10 minutes, I think it will cut, but please, we have to rejoin, okay? So let's M1 times V1 over, now this is M2. So 1/4 of M1 times, this is V2. V2 is 5/2 of V1. So we have P1 on P2 is equal to 1/, this is 5/8. We are looking for P2. So let's make P2 the subject. P2 will be equal to 5 on 8 times P1. The question gave us the initial momentum, 8.25. So 8.25 times 5 on 8. Please multiply and then give me the final value. 8.25 times 5 on 8.
165/32.
And give me, Adma, give me the final value in decimal.
5.12.
5.12 kilogram meter per second is the new momentum if there is that change. So it's not much of a difficult question, but in fact, you must understand the statements or the information given and then apply. I was also solving this using fraction. The speed increased by 3 on 2. There's an increase. Let's change 3 on 2 to fraction. 3 on 2 times 100%. Okay, 100% is 100 over 100. So this is 50. Okay, so I have 150 over 100, which is 150%. So it means that the speed increased by 150%. So V2 is equal to, the original percentage is 100. Then 150% was added. So you know we have 250% for V2. So V1 increased by 250%. That will be for V1, V2. 250% of the initial value. Then let's look at masses. M2, we are told that it is decreased by 3 on 4. Let's express 3 on 4 as a percentage. 100 over 100. This is 25. 25 times 3, we have 75. So it means the mass was reduced by 75%. So what is actually left? M2, what will be left is equal to 25%. Okay. What will be left for mass will be 25% because it was decreased by 75%. So P1, I'm coming, let me clean the board very well. P1 is the same, M1, V1. P2 is, P2 in terms of mass, 25% over 100 of M1 times V2. V2, we have 250% of V1. If you take the ratio, yes, you have P1 on P2 equals to, the masses will cancel. So 1 over 25 over 100 times 250 over 100 is actually 25 on 10. Okay. Now, you can change this to fraction. 25 over 100 is 1 on 4. 1 on 4. Okay, this is also 5 on 2. So it brings us back to what we were looking at, a total fraction of 5 on 8. So you have P1 on P2 giving you, this is 1 on 5 on 8, which is 8 on 5. 8 on 5. Therefore, P2 would be equal to 5 on 8 times P1. And it brings us back to this point. So whichever way you look at, whether fraction or percentage, you get the same value. So class, this is not so difficult, but you need to take your time, listen, and then apply. And these are things I know you can all easily apply, but because you haven't solved such a problem before, that is the reason for which the question looked a bit scary. But it's not so scary like that. Class, are we okay?
Yes.
Aresi?
Sir.
Are you fine?
Yes, please.
Yes.
Okay. So we are going to use the coefficient of restitution thing we learned to solve problem. So you master how to use that in solving problems. And so I'm going to send to you a particular question. Let me forward this to the group. So I've sent a question to the group. Please take note. Question 7, question 6, and the other one, I think you'll solve it. But let's look at question 7. A tennis ball of mass M1 equals 0.04 kilogram, moving with a speed of 5 meters per second, has an elastic head-on collision with a target ball of mass M2, which is equal to 0.06 kilogram, that was moving at a speed of 3 meters per second. What is the velocity of each ball after the collision if the two balls are moving A? If they are moving A in the same direction, B in opposite direction. So we are looking at the two balls, okay, and calculating for their final velocities if they move in the same direction and they move in the opposite direction. That is the problem we have to solve for now. Okay, so let me clean my board. Then we look at how we can solve a kind of problem like this. And this is the main area you need to understand under elastic collision. As for inelastic collision, it's not difficult. But when you have an